Hi everyone. Today's lesson is going to come in the form of two videos. The first video is going to go over the atomic model that we're going to be using this year to describe the atom. And the second video that you're going to watch separately and continue to take notes on is about how we develop these atomic models. So first off, what you're going to learn in these two videos is you're going to learn how to explain what a scientific model is. You're going to be able to identify the basic structures of an atom, and you're going to understand how we know these are the structures of an atom and how our understanding of this has changed over time. So let's review. A scientific model is an explanation of a natural phenomena. It is based on some sort of observable evidence, and when we have new evidence, the scientific model can change. Now, scientific models have limits. They explain one aspect of how something behaves, and they have really limited uses. And scientific models can come in many different forms. It can be a graph, it can be an analogy, it can be a mathematical equation, it can be a picture diagram, or it can be a written and spoken explanation. So this is really similar to one of the atomic models that you guys drew. A lot of you guys drew, some people drew just like a little dot to show how small an atom was. A lot of people drew positive and negatives, and you knew things were flying around. So this is an example. And what you're going to do in your notes is you're going to label the different parts so you guys can see this one has protons on it. So you'll label the protons, and then I'm going to go over the characteristics of each of the parts, and you just write down some notes right underneath the label on your chart. So the first particle we're looking at here is a proton, and you see here that it's the positively charged particle. On your paper, of course, it's gray, but it has a little plus on it. And a proton has a positive charge. It is located in the nucleus of the atom, and it has a special mass. The mass of a proton is close to 1 atomic mass unit. These particles are so small that they actually have a special unit of measure to measure how massive they are. And the interesting thing about the proton is that the number of protons actually identifies what the element is. So for example, hydrogen has 1 proton. If you add another proton, now it's helium. If you add a following proton, 3 protons, it's lithium. And it continues from there. So the proton is like the identifying factor. So the next particle that we're going to look at is called the neutron. It's also located in the nucleus. I would suggest on your notes, you might want to put your notes over in this section. The neutron, again, is located inside the nucleus. That's actually where all the mass of the atom is located, even though it is teeny tiny in terms of its volume. And the neutron has no charge, which is really good, because if it was all positive charges in the nucleus of the atom, then protons would just repel each other. So the neutron being in there helps to balance out the forces that would repel the protons. It's actually a nuclear force that ends up holding it together. And like the proton, a neutron has a mass of 1 atomic mass unit. All these particles are located, so the particles we've gone over so far, the protons and neutrons, are all located in the nucleus. And the nucleus is the center of the atom. And just like the nucleus of a cell contains DNA, which is the identifying material, the nucleus of an atom contains the protons, which are the identifying material of an atom. The nucleus itself actually takes up very little space, but it has nearly the entire mass of the atom. And lastly, we have the electron. The electrons are located on the outside of the nucleus. They have a -1 charge, and their mass is super tiny. It's 0.0 with like 18 zeros, 1 atomic mass units. So we basically just call it 0 because it doesn't really matter. And I'll explain that a little bit more in detail in class. But they are responsible, because they're on the outside of the nucleus, they're actually responsible for all the chemical interactions and reactions, because sharing the electrons, losing electrons, gaining electrons is actually what ends up forming chemical bonds. So now that you know our basic understanding of the parts of an atom, in our next video we're going to go into why we understand these to be the parts of the atom.